Hi guys, welcome to lecture 6. In the previous lecture we have seen how the general form of equation can be transformed to slope intercept and normal form so that we can find the slope and the x-intercept and y-intercept. Today we will see how to find distance of a point from a line. First thing, what does mean by the distance of a point from a line? Let's say this is a line L and this is a point P x1 comma y1. So the distance of this point P x1 comma y1 from a line is nothing but the distance of the perpendicular drawn from P to the line L. Okay, I will draw here. Draw a perpendicular from P to the line L. Let's say this is the point M such that PM is perpendicular to line L. Okay, so this length of PM, let's say this is D. This D is the distance of a point from a line. So we need to find the distance D here. Let's assume this line as a standard form, which is ax plus by plus c equals to 0. This line L intersects x-axis and y-axis at this point, intersects y-axis at this point. What will be this point? This point is nothing but x-intercept, which is minus c by a comma 0. Or else you can solve it. The equation is ax plus by plus c. As this point is on x-axis, its ordinate is 0. So substitute y equal to 0 here. Y equals to 0, which implies ax plus c equals to 0. That implies x equal to minus c by a. Okay. Similarly, if you put x equal to 0, we get y equal to minus c by b, which is this point 0 comma minus c by b. So now we got these 2 points. Let's name it. This is some q, this is some r. Now if you observe, we have 3 points p, q, r. Then the triangle formed by these 3 points. This is the triangle formed by these 2 points, these 3 points p, q, r. Now we need to find distance d. D is nothing but the height drawn from P of this triangle PQR. What is D here? D, the distance D which we need to find is the length of height drawn from P of triangle PQR, drawn from P to the base QR. So we need to find the height from P, which is D. How do we find it? We need to find one unknown, which is D. If you observe in the triangle PQR, we know these 3 points because P is given, which is not unknown. P is given, and Q and R also known from the line equation ax plus by plus c equal to 0. So these 3 points are known. So we will get the area of triangle using this formula which we have derived in the lecture 1. If you forgot, I am just recapping it. See, if you know 3 points, then we can find the area of triangle, which is half into modulus of x1 into y2 minus y3, x2 into y3 minus y1, x3 into y1 minus y2. I have shown here x proof also. If you haven't seen, you can watch the lecture 1. So now we will get the area of this triangle because we know these 3 points. Okay, but we know that area of triangle PQR equals half into base b into h height. We know this. Height is nothing but d, which we need to find. Base is nothing but qr. So we know q and r, so we'll get the qr distance by using distance between 2 points formula. Okay. So, and we know the area also. If we equate this area and the area which we got from these 3 points, then we will get d. Okay, did you get the concept? See, we will do here. So base b equals qr. We know q and we know r, which is nothing but distance between 2 points formula, which is x2 minus x1 whole square. What is x2 here? 0 minus c by a. 0 minus c by a whole square plus y2 minus y1 whole square. What is y2 here? Minus c by b. y2 is 0. So minus c by b whole square. So we get root over c square by a square plus c square by b square, which equals root over a square plus b square by, if you take LCM of a square and b square, you will get a square into b square, and in the numerator we get a square plus b square. If you take outside, we get c by ab, and we need to take modulus because the length is positive. Okay, so we know the base, and what is height here? Height equals d, distance d, which we need to find. I will mark it as red. We need to find d. Okay, we need to find distance d. Okay, so we know the area equals half, let me be clear, area of triangle PQR equals half into, what is base here? Modulus of c by ab into root over a square plus b square into what is height here? D. So this is the area of triangle PQR. And we also know that as we know 3 points, we can find the area of triangle PQR in another formula, which is QR equals half into, what is it formula? x1. x1 is nothing but, let's say this is x1 y1, this is x2 y2, this is x3 y3. So x1 into, if you confused, I will write here p x1 comma y1. What is q here? 0 comma r is minus c by a comma 0. And what is q here? Q is 0 comma minus c by b. So we know these 3 points. Then let's see how we write area of this triangle PQR. Half into x1 into y2 is 0 minus y3 is minus c by b, which is x1 into 0 minus c by b. Okay, did you understand? Plus minus c by a, similar, minus c by into minus c by b minus y1 plus 0 into y1 minus 0 modulus, which gives half into modulus of x1 into c by b plus y1 into c by a plus, this is c square by ab, c square by ab. Now if you take c by ab outside, because we have taken for this area, so just to be simplify, half into modulus of C by AB into modulus of, if you take C by AB common, you get AX1 plus BY1. See, if you multiply C by AB into A, you get C by B, which is x1 coefficient here. If you multiply C by AB with B, you get C by A, which is y1 coefficient. So, which is C. If you observe AX1 plus BY1 plus C, which is same as the line equation L with x and y substituted by x1 comma y1. Now, we need to compare the area which we got here. This is 1 and this is 2. We need to compare 1 and 2. We need to equate these two. That implies 1 equals to 2, which is modulus of C by AB into root over A square plus B square equals half into, sorry, there is an half. Yeah, there is an half in this side also. Half into modulus of C by AB into modulus of AX1 plus BY1 plus C. C by AB cancels into D here, and off cancels, which gives D, distance D, which we need to find, is D equals modulus of AX1 plus BY1 plus C by root over A square plus B square. So the distance D from a point to a line is nothing but modulus of AX1 plus BY1 plus C, which is nothing but we need to substitute this point P, x1 comma y1 in the line AX1 plus AX plus BY plus C, and divide it with root over A square plus B square. A is x1 coefficient, B is y1 coefficient. So this is D. Let's box it. So this is the D, distance D from a point to a line. Now we will see how to find distance between two parallel lines. Distance between two parallel lines. Distance between two parallel lines. Okay. What is meant by distance between two parallel lines? Let's have a graphical view. Let's say this is a line L1 and there is another line L2 which is parallel. It is parallel to this line. L1 and L2, these two are parallel. So if these two are parallel, we know that the distance, perpendicular distance, is same everywhere. This is D, and everywhere the distance is same because they don't intersect at all. So we need to find this distance D. This distance D. How do you find it? Let's see. We will use the previous one, which is distance between a point and a line. to obtain this result, distance between two parallel. Let's say this line L1 is y equal to mx plus c1, and this point is y equals mx plus c2. See, as these two lines are parallel, slopes are equal. Okay, so only difference is c1 and c2 here, the constants. So the line L1 intersects x-axis at the point. See, you have to put y equal to 0, which means x equal to minus c1 by m. So this point is minus c1 by m comma 0. So we know a point of this line L1. So we know a point minus c1 by m comma 0. Let's say this is some p, and we know a line L2 which is y equal to mx plus c2. So if we apply the previous formula, the distance between point P and the line L2, which means the distance d equals what you have seen here. We have to just substitute minus c1 by m comma 0 instead of x and y in the equation of line L2, which gives modulus of y1 minus mx1 minus c2 modulus by root over the x coefficient is minus m, which is m square, and the y coefficient is 1, which is 1. So what is y1 here? y1 is 0 and x1 is minus c1 by m, which gives modulus of 0 minus m into x1 is minus c1 by m minus c2 by root over m square plus 1. We just found a point of L1, and we found the distance from this point to the line L2, which is same as distance between these two lines, which gives mm gets cancelled. You get c1 modulus of c1 minus c2 by root over m square plus 1. So we get distance between these two lines as c1 minus c2 modulus by root over m square plus 1. So here we represented line L1 and L2 as y equal to mx plus c, which is slope and intercept form. Suppose let it be general form, which is ax plus by plus c equals to 0. In lecture 4, we have reduced this to slope intercept form. Then what we got is y equals minus a by b x minus c by b. So here the slope is minus a by b and constant is minus c by b. So let L1 may be ax1 plus by plus c1, and L2 be ax plus by plus c2. The coefficients of x and y doesn't change because the slopes are equal, which gives y equals minus a by b x minus c2 by b. So substitute m as minus a by b and substitute c1 as minus c1 by b and c2 as minus c2 by b, which gives distance d equals modulus of c1 minus c2 by root over a square plus b square. This is distance between ax plus by plus c1 equals to 0 and ax plus by plus c2 equals to 0. Just we need to substitute m as minus a by b, which gives a square by b square plus 1. If we take b to the numerator side, we get a square plus b square by b square. Whereas in the numerator, c1 minus c2 is substituted as c1 minus c2 by b, and that b and the b in the denominator cancels. So we get c1 minus c2 by root over a square plus b square. This is the distance between two lines in a general form, where a and b are coefficients of x and y, c1, c2 are the constants. Thank you.